When you walk through a city park, a university campus, or even a neighborhood street, you're not just looking at trees. You're looking at a managed system, a living infrastructure that requires planning, data, and long-term strategy. For arborists preparing for the BCMA exam, understanding tree inventory and management planning is essential. This is where arboriculture intersects with policy, planning, risk management, and sustainability. Today, we're going to explore how arborists organize information about trees, how they assess risk and resources, and how those insights become a functional urban forest management plan. And if you work in municipal or consulting arboriculture, this is the kind of work that defines your professional impact. Let's start with the foundation. Tree management begins with understanding what trees you actually have. That process starts with a tree inventory. A tree inventory is a systematic collection of information about trees within a defined area. That could be a city park system, a university campus, a utility corridor, or an entire municipality. Arborists record information such as species, condition, diameter at breast height, commonly abbreviated as DBH, location, risk level, and maintenance needs. Modern inventories often rely on tools like Global Positioning System Technology, or GPS, which allows arborists to map tree locations with precision. Those spatial coordinates can then be imported into a Geographic Information System, or GIS, which allows arborists and planners to visualize and analyze the urban forest across an entire landscape. When inventories become large, analytical tools like iTree are often used. The iTree software suite helps quantify ecosystem services such as carbon sequestration, pollution removal, and stormwater interception. This data is incredibly valuable for city planners and policymakers, because trees are not just aesthetic elements, they are part of a functioning ecosystem. An ecosystem is a community of living organisms interacting with their physical environment. In urban environments, trees support biodiversity, provide wildlife habitat, and influence local microenvironment conditions such as temperature and humidity. These ecological contributions are known as ecosystem services. Urban forests provide services like carbon sequestration, which helps mitigate the greenhouse effect by storing atmospheric carbon in woody biomass. They also reduce stormwater runoff by intercepting rainfall and improving soil infiltration. When cities begin to recognize these services, trees become integrated into broader green infrastructure planning. Green infrastructure includes systems designed to manage environmental challenges naturally. Trees, green roofs, bioswales, and permeable landscapes all contribute to urban sustainability. Programs like Leadership in Energy and Environmental Design, often called LEAD, and the Sustainable Sites Initiative, or SSI, promote design strategies that incorporate vegetation and soil systems to improve environmental performance. This is where arboriculture intersects with landscape architecture and urban planning. And it's why tree inventories are so important, because effective management requires data. Now, inventories also inform something called resource assessment. Resource assessment evaluates the condition, distribution, and value of tree assets within a community or organization. For example, an inventory might reveal that a city has a monoculture problem. A monoculture occurs when a large percentage of the urban forest is dominated by one species. History has shown how dangerous that can be. Think about Dutch elm disease or emerald ash borer. To prevent catastrophic loss, urban foresters promote species diversity. Species diversity spreads risk and improves overall ecosystem resilience. In fact, diversity planning often involves careful consideration of native species, introduced species, and naturalized species. Native species evolved within the local ecosystem. Introduced species are brought from other regions intentionally. Naturalized species are introduced species that have adapted and reproduce in the new environment. However, some introduced plants become invasive species, meaning they spread aggressively and disrupt native ecosystems. Arborists must understand these distinctions when developing planting strategies. And speaking of planting, successful tree establishment begins with proper planting specifications. Planting specifications outline how trees should be installed, including soil preparation, planting depth, staking methods, and irrigation requirements. These specifications often incorporate best management practices, commonly referred to as BMPs. BMPs represent widely accepted methods that reflect current professional knowledge. They guide arborists toward consistent, high-quality work. Another critical planning concept involves the planting site. The planting site determines whether a tree can thrive long-term. Arborists evaluate soil volume, drainage, compaction, sunlight exposure, and nearby hardscape. Hardscape refers to non-living landscape elements like sidewalks, roads, and buildings. These features often limit root growth. To overcome this, designers sometimes install structural soil or suspended pavement systems. Structural soil is engineered to support pavement loads while allowing root growth. Suspended pavement systems hold pavement above soil, creating large uncompacted root zones beneath. Another design solution involves tree islands. A tree island is an open soil area within paved surfaces where trees can grow. These systems dramatically improve root health in urban planting sites. Of course, soil conditions matter as well. Sometimes sites contain engineered fill, which is compacted soil material used in construction. Engineered fill can restrict root penetration and water movement. That's why arborists must carefully review grading plans before construction begins. A grading plan shows how soil elevations will be altered during development. Poor grading decisions can bury root systems or redirect drainage in ways that stress trees. This brings us to one of the most important concepts in tree preservation during construction: the critical root zone, or CRZ. The CRZ represents the area around a tree, where the majority of essential roots are located. Protection of this zone is vital during development projects. To protect roots, arborists often establish a root protection zone, or a tree protection zone, abbreviated as TPZ. The tree protection zone is physically marked with a tree protection zone barrier, or TPZB, which prevents equipment from entering the protected area. In some cases, tunneling or horizontal boring techniques are used to install utilities without damaging roots. These methods allow pipes or conduits to pass beneath root systems with minimal disturbance. This is especially important when dealing with underground service lines or electric utility infrastructure. Service lines, sometimes called service drops, connect buildings to utility systems. Poor installation practices can severely damage roots. Careful planning prevents these problems. Now let's shift to the human side of tree management. Urban forests are managed by professionals with various titles. A municipal arborist typically oversees tree care within city limits. An urban forester focuses on broader planning and management of the urban forest ecosystem. Some communities appoint a tree warden or tree officer responsible for enforcement of tree policies. A city forester may oversee planting programs, inventory management, and public outreach. All of these roles operate within the framework of urban forestry. Urban forestry is the management of trees in cities and towns to improve environmental quality, public health, and community well-being. These professionals often implement a comprehensive urban forest management plan. An urban forest management plan outlines goals, strategies, budgets, and maintenance schedules for managing a community's tree population. And that brings us back to inventory data. Inventory data helps establish pruning cycles. A pruning cycle is the interval between scheduled pruning operations. For example, a city may maintain a 5-year pruning cycle for street trees. This ensures regular inspection and structural pruning, while distributing costs evenly. Maintenance planning also includes pest management. Integrated pest management, or IPM, focuses on monitoring pests and applying control methods only when necessary. Similarly, integrated vegetation management, or IVM, is commonly used along electric utility corridors to manage plant growth safely and efficiently. These programs rely on action thresholds. An action threshold is the point at which pest populations or damage levels justify intervention. This prevents unnecessary chemical treatments and promotes ecological balance. A related strategy is plant health care, often abbreviated as PHC. PHC is a proactive management approach that focuses on maintaining overall plant health through soil management, proper species selection, and early problem detection. Now, here's an important concept for the BCMA exam. Tree management is deeply connected to risk management. Arborists regularly perform tree risk assessment to determine the likelihood of failure and potential targets. Risk levels are often categorized as acceptable risk, unacceptable risk, or somewhere in between. An acceptable risk level is one where the probability of harm is considered tolerable. Unacceptable risk indicates a hazard that requires mitigation. This evaluation forms the basis of tree risk management decisions. Risk management also relates to legal responsibilities. Arborists and municipalities have a duty of care to maintain trees in a reasonably safe condition. The standard of care refers to the level of competence expected from professionals in the field. Standards and specifications guide this process. A standard describes what must be achieved. Specifications describe how the work should be performed. These documents often reference industry guidelines and best management practices. Municipalities frequently enforce these standards through a tree ordinance. A tree ordinance is a local law regulating planting, removal, and protection of trees. Some areas also issue tree preservation orders, often called TPOs, to protect significant trees. These may include ancient trees or champion trees. An ancient tree is one that has reached exceptional age relative to its species. A champion tree is typically the largest known specimen of a species within a defined region. These trees often hold cultural, ecological, or historical significance. Managing them requires careful planning and sometimes special permits. Permits are official approvals required before certain actions, like tree removal or major pruning, can occur. Permits help ensure that tree management aligns with community policies. Now let's consider the broader landscape context. Tree planning must consider facilities, buildings, sidewalks, and utilities. Design criteria help determine how trees fit within these systems. Design criteria may specify mature height limits, planting distances from infrastructure, and allowable species lists. Low-growing plant communities may be used under power lines to reduce conflicts with electric utility systems. Selective management strategies help maintain appropriate vegetation in these areas while preserving ecological function. In addition, arborists must consider landscape function. Landscape function describes the role vegetation plays in environmental performance. Trees may provide shade, reduce heat islands, filter pollutants, support wildlife, or enhance aesthetics. Each planting decision contributes to the larger system, and that system includes stakeholders. Stakeholders include residents, property owners, government agencies, developers, and environmental groups. Effective urban forestry requires balancing their interests. For example, development projects often occur on land with easements, and an easement grants limited rights to use a property for specific purposes, like utility access. Arborists must work within these constraints when planning tree preservation or planting. Now here's something worth remembering for the exam. Urban forest sustainability depends on long-term planning. Sustainability means managing resources in ways that meet present needs without compromising future generations. Healthy urban forests support biodiversity, provide habitat for wildlife, and improve environmental quality. And they do so only when managed thoughtfully. That management begins with data. Tree inventories, resource assessments, and GIS mapping help professionals understand what exists. Management plans translate that information into action. Summary: tree inventory provides the data. Resource assessment interprets that data. Urban forest management plans guide long-term decisions. Risk assessment protects public safety. Planting specifications and BMPs guide installation and maintenance. And sustainability ensures the system remains healthy for decades to come. In the next chapter, we'll continue building on these ideas by exploring advanced diagnostics and how arborists interpret complex tree health issues in the field, because understanding trees at a systems level is what transforms a good arborist into a master arborist.
Thanks for listening to the Arborist podcast. Let's keep building your arborist knowledge one domain at a time. If you found this useful, please like and subscribe.